This conference will
will
now be
be
recorded.
duration of 7 years. Now, Sar is working as a principal in the PC College of Engineering, Goa, since August 2017. Sir did his BE in Industrial Process Engineering in 1990, ME in Professional Management in 1996, PhD in Mechanical Engineering from Indian Institute of Technology, Kharagpur in the year 2008. Sar has published many papers in international journals, nearly 55, and he presented papers in English conferences, nearly 10. And Sar is editor for many reputed international journals. He is reviewer for International Journal of System Assurance Engineering Management, Springer publication, then Silicon Springer publication, Neurocomputing, Elsevier publications, Journal of Manufacturing Process, Elsevier, Journal of Process Mechanical Engineering, SACE publication, Journal of Advanced Manufacturing Technologies, Springer publication, Journal of Mechanical Science and Technology, Springer publication, and many more are there. And he is advisor for many technical committees. He has delivered lecture in many invited lectures. Sar has graded PhD with the title Modeling and Analysis of Pressure Die Casting Process using Conventional Regression and Soft Computing Based Approaches from Visvesvaraya Technological University, Belgaum, Karnataka. And Sar has membership in many professional bodies like Indian Society for Technical Education, Institute of Engineers, Asian Council of Science and Editors. And Sar has visited abroad countries to deliver his research papers in Romania. And Sar has published a book titled Mixing of Hard Materials, a comprehensive approach to experimentation, modeling and optimization, manufacturing and surface engineering. It is Springer Publications. I am very glad to inform to all the participants who have got the opportunity, such an experienced person who is participating through online to enlighten us on the concept of optimization through soft computing techniques. Hope we have the fruitful section with Dr. Mahesh sir. Welcome, sir.
Thank you. Thank you.
Accepting our invitation. Please start your section, sir.
Okay. Very good morning. Thank you, Dr. Sridhar, for introducing me to this forum. See, my topic here for discussion today is optimization through soft computing techniques. So if you look at the structure of my address, today's address, so structure of my seminar or the address, it is the optimization tools and techniques. See, the seminar is mainly focused on the optimization, the tools. Of course, in the operations management, see, but if you have the basic idea of what are the optimization tools and which tool will be better for your particular application, so it is necessary to have some the basic knowledge about the selection of the tools and what are the different tools that are available for you people. Especially these mainly the focus is for the research people. Maybe it's very much useful. So basically we'll be dealing with the optimization, what are the different the nature of the optimization problems we can deal, and the optimization techniques and the classification, the brief classification. And mainly as my topic is mentioning about the soft computing, so there are plenty of algorithms, so out of which I'll be discussing 4 different types of the optimization techniques which are used for all the applications. Now, then we'll take up the all these algorithms what I discussed. So one application, it will be better, you know, we can understand the entire process when we apply it to some the case studies. So the application I have taken here is the machining process. See, here I am briefly going for the modeling also, because why modeling is required. See, unless you have the model, it's not possible to have the optimization. So modeling of the system is also equally important. So briefly, I will be dealing with the modeling of the systems, that is pertaining to the case study. So under that, I'll also brief, you know, what are the different tools which are used and how the modeling of the machining process is done. So that I will be explaining. Then coming to the multi-objective optimization, the case study which that is applied to the algorithms what we are going to discuss. So it will be all four the optimization techniques are applied, and it will be their performances will be compared, and of course we'll be drawing some conclusions from the present work. Now, see, optimization. So what do you mean by the optimization process? Why it is so much of importance for the, especially for the engineers? Now, as you know, it is in the simple words, we can say the optimization process is identifying and determining the most suitable and the best the solution, because there may be solutions we can basically classify as the basic solution, feasible solution, then optimum solution. So the goal here is to go for the optimum solution, because the many of the decision makers, especially maybe it is in the service or maybe in the manufacturing, so the decision makers need solutions. So what type of solutions they'll be looking for? They'll be looking for the best of the solution for the given situation. So these solutions, the optimum solutions, are very important. See, if the case is a the simple one, maybe considering of only very few variables, then it is. But the real world problem, if you take the situation, it is much more complex. There will be so many variables, so many objective functions. You need to go for the multiple objective function optimization, where some of the objective functions are of a maximization type, some are of minimization types. So variety of the complex situation will be there in the real world. So that is why you should have the knowledge of the multi-objective function optimization as well. Because if you try to get the in isolation the solution for that problem, with one considering only one objective, maybe probably that may be not the good solution for the overall situation. So that is why the optimization is an important the technique people should, engineers should know where it is going to affect the decision. So these decision will have the impact in terms of many things, like the efficiency of the process, then finally the productivity, finally the capital gains, finally the profit. Because you know all the organizations, they will be looking for the maximizing their efficiency and maximizing the profit. So for that they need to take a decision at different stages. Maybe it is a financial, maybe it is the operations management, maybe it is a manufacturing, under manufacturing also, maybe some different the processes. So it is the number of stages the decisions needs to be taken. So those decisions, the optimization is the process where they can make the scientific decisions which are going to yield definitely the better results. Now, classification of the optimization, of course, will based on the nature of the equations in the objective function. Of course, you all know the linear optimization problems, nonlinear optimization problems. That is, if at all the decision variables, so if they are having the power function in that the objective function, it is a nonlinear. Linear optimization were very simple cases, but most of the real world the problems are nonlinear in nature. So when you try to apply, so you will come to know. So whether the given problem is linear or non-linear, so that also can be decided by establishing that relationship. That we'll see when we go for the modeling part. Then based on the existence of any functional constraint, so we can see the unconstrained optimization. That means there is no restrictions, but the problems of such types are very less, whereas most of the optimization problems have certain restrictions in which they need to work. Now, based on the nature of the design variable, we have the integer programming, real valued programming, and mixed integer programming. Of course, it is based on that one. There are two major types of optimization algorithms. Now, we will come to the next part, that are what are the optimization algorithms. We know now understood what is the importance of optimization and why it is required. Now, what are the algorithms that are available? So if you understand these to some extent, so you will come to know which algorithm when you need to use. Now because see, all these optimization means it is searching the solution in the space. That design space will be there, where the response will be there, the response surface will be there. So they will be, looking for the optimum solution by means of the search procedure. So that is a deterministic approach is there. Those are the conventional optimization techniques. There are plenty. Maybe based on the statistical models, Taguchi techniques, DOE is used, some linear the programming, dynamic programming, so many are there. So these are deterministic. That means the solution what we are going to get through this deterministic search procedure, it is much accurate compared to other soft computing based algorithm. But the problem is here it is not so easy to apply, especially when you have the complex problems. Complex problems means whenever, because most of the real world situation are multidimensional and the multimodal. If you look at the surface of the responses where it needs to be minimized or maximized to optimize that one to get one. So most of the things, the deterministic search procedure, it becomes more difficult. So that is why another set of the stochastic algorithm or the non-conventional optimization techniques are into the picture. So these are the heuristic search. See what is going to happen in all the conventional process of optimization. The optimization or the search starts at certain points, whereas here the non-conventional optimization techniques, the search is going to begin in the space at multiple points, and it is the number of iterations will take place, and trying to get the solution which is more closer to the real optimization. That means here the solutions what we are going to get is the approximate solutions, not like the deterministic search procedure where you are going to get the accurate results. Here we are going to get the solutions which are more approximate in nature but closer to the real optimum solution. But the main advantage of this, you can use these techniques. These techniques are, you can get the more complex situation in a multi-dimensional space, the search can be done. So that is the advantage of stochastic algorithms. That is which is based on heuristic search at many points. So another thing is it will not see the other the problems. They need the mathematical formulation. See, of course, here also mathematical formulation is required to establish the model, but to solve that, not much of the complicated mathematics is involved. Now, compared to the classification, if you consider, so this classification. So this classification is a linear programming methods. As you see, is a very simple graphical method, all might be knowing, where there are only two variables which can be solved. You can get the solution very easily and accurate, much accurate. As the number of the variables increases, the solutions will be in the multi-dimensional, where it is difficult to visualize the graphs and get the solution. Then we have the nonlinear programming methods, the all classification. These are the basic things you might be knowing. Some of the search, they are working on the gradient based, that is the search based on the gradient. Then we have some specialized algorithms like integer programming, geometric programming, and dynamic programming. Now, what are the drawbacks of the traditional optimization? Now, so far we discussed the major classification. One is the deterministic approaches and the stochastic approaches. So, whereas the conventional method, which is based on the mathematics, so we do not know the nature of the response surface. See, if you look at here, see, this is the, suppose if this is the response surface which is resulted, that means which is going to represent the input output relation, maybe in the multidimensional or two dimensional, depending on the number of variables. Now, what is going to happen here? So we can see the two bases. One base is here, it is obtained, and another one is this one. This is the entire surface which is representing the relation. We want, see, the if the problem is to minimize, then what is going to happen? If you use the conventional optimization algorithms, that is the probability of because if it is a gradient search or other method, so the search is not going to start at the many of the points. So it is what is going to happen. So all the probabilities, see here, again it starts increasing. So the solution what we get, most of the times it may be local the solution. See, which is the global solution for the given response surface. This is it is not going to reach this point at all. What is the reason? Because the solution it will be stuck here itself, because it assumes there is again starts the increase in the value, so it will stuck here. So this is a local minimization, local solution, local optimum, which may not be the exact solution which you are looking for. So probability are very high. Only it all see, it depends, the nature of the problem. See, if it is like only the model is like this, only like this parabola, then which method is suitable? So the conventional method is the best one, because there is only one point, the local minima and global minima are one and the same. That means it depends on the nature of the surface, whether this is a multimodal. See, there are two peaks. So if it is having more than one peak, so which solution, which the techniques are better? The techniques which are better is the global, the soft computing based techniques will be much better. So this is one of the drawback. Since many of the given problems, the realistic problems, they are of the multimodal and multidimensional. So this is one major problem with the conventional optimization technique. Then for the discontinued objectives function also, see there here you can see the response surface, it is continuous. If it is the discontinuous, some part here, some part here, then again the conventional problems, conventional optimization will have some problems. And there is a chance of the solution of a gradient base. That's what I discussed now. The discrete variables are difficult to handle using the traditional method. That means the input variables, when they are discrete, it becomes difficult, not suitable for the parallel computing. And also particular traditional method of optimization may not be suitable to solve all variety of problems, since the real world problems consisting of a number of variables and in a multidimensional and a multimodal, so it is difficult. Now we'll come to the optimization tools one by one. We'll discuss first the genetic the algorithm. See, before that, coming to the genetic algorithm, I would like to explain how the soft computing based algorithms, they are classified. See, soft computing, the word which is used, unconventional. See, these the tools are derived based on the nature and biology. So that is the inspiration. So based on that, the optimization tools have been developed. Now there are the algorithms which are based on evolutionary algorithms, like the genetic algorithm will be there, then the evolutionary algorithm, then differential evolution. So these are all the algorithms which are based on, they are based on the evolution, based on the nature, based on the biology. Then we have the another class of the optimization techniques of computing, that is a swarm intelligence based the optimization techniques, like the particle swarm optical the particle swarm optimization techniques, that is ant bee colony, ABC colony. So these are based on the movement of the birds, the flocking of their wings. So based on that, these are developed, and some are based on the natural phenomena, like that group is based on the harmonic search, gravitational search. So these are all based on the natural phenomena. That is the how these are classified. But all these things what I told so far, that is the evolutionary algorithms or the algorithms which are based on the swarm intelligence or the algorithms which are based on the natural phenomena. So these algorithm, there are these, they need the algorithm specific parameters will be there. See, the algorithm specific parameter means if you want to use that algorithm, there are certain parameters that you need to set them at a certain optimum value. That means these algorithms, you need to, before using these algorithms for your current situation, that algorithm, there are a certain parameters which you need to optimize. So the GA might have the crossover probability, mutation probability. So some of the parameters will be there. So which are that are algorithmic specific. That is the size of the population. So some of the problem related the parameters, and some are the algorithm specific parameters. So all these the evolutionary algorithms, they need the algorithm specific parameters needs to be set, they need to be determined for a particular situation. Now there are the another set of the algorithms which are developed by Rao, I think the professor of in Surat VNIT. So those were the algorithms which are not having any the algorithm specific parameters. So the difference here, see here, when you are using these evolutionary algorithms and all these algorithms, it is the complexity, the computational time is more, the computational complexity is more. Why the time is more? So before using that, so you need to determine some of the parameters which are best suitable for your particular problem. So which is not the case with the help of the algorithms like the Jaya algorithm is there. Then the teacher learning based algorithms are there. So those are the algorithms, evolutionary algorithms, which are used not without any the algorithm specific parameter, so that the process is much faster compared to the evolutionary algorithms. Now we'll discuss this the optimization tool, that is the genetic algorithm. So this is developed by, of course, people are using this from the long time, which was proposed by the Charles Darwin. That is the basis of the concept of the biology. The biologically inspired algorithm. So it is a part of the evolutionary algorithm, as I discussed, wherein a set of possible solutions are generated from the population which is included in the chromosomes. See now, all these the algorithms, soft computing algorithms. So it is going to start with a set of the initial solutions, so which are generated at random. See, these solutions, they are known as the population based solutions. So because see, as I mentioned, the search is going to start at the several distinct points in the design space. So we have the number of the solutions are started, we are going to start with the GA also, that is with the initializing the population. That means a number of maybe 10, 20, 50, 100. So more the number of the initial solutions, so it is going to take more time, but of course the convergence time or the accuracy of the result what you get, that may be good. That is why it depends. So what will be the population size? The population size that needs to be determined. Now, how they process it is, of course, the GA, it has the two types, that is the binary coded GA and the real coded GA. See, the binary coded GA, the binary coded GA string. See, now here you can see. See here, this is the binary coded string. That means that this entire string, what it is going to represent? So this is going to represent one solution of your problem. See, one of the solution. See, there will be the population, the entire population, that is the initial population generated at random, means these binary coded GA string is generated at random. Maybe the length of binary coded GA depends on the number of parameters and how many the bits you are going to use for to represent that the decision variable. So here, so what these are going to represent? See, these are x1, x2, x3, x4 up to xn, and each here you're going to have the string length of 4. That means suppose there are the n number of variables in your system. That means the variables means the variables which are affecting the process which you are considering, the process for which you are looking for a solution. So if it is having a n number of the variables, so each variable is represented here by, see, the 4-bit. See, that means how? That means, see, that whatever the value of that the variable is there, so that needs to be converted and represented in the form of the, see, this binary coded, see, it is generated at random. See, this you can convert it into the real value. So the string is going to represent all the number of the all variables and their values. So if suppose there are the 100 is the bit length, which is the string length considering of the 10 variables. So each variable is represented by 10 binary bits. So the number of bits here, see, it can be the 4 number, 3 number, 5 number, each variable, how many bits it will be represented, whether it is a 4, 5, 6. Again, that depends on the accuracy. If you take the more the number of bits in a primary, the binary coded that string for to represent a particular variable, then what is going to get, the solution you are going to get will have the more accurate. Of course, see, when naturally when the length of the string is going to increase, so what is going to happen? The complexity is going to increase. The computational time what it is going to take is also going to increase. So this the how it is then the real coded GA. See, most of the times, of course, the more popular among the binary and real coded is the binary coded. People use the binary coded GA in more. So the real coded GA, so where the inputs you can the directly put by converting them using the some formula. See, now the process that is involved in GA. So we are going to start with the process where, as I told, initial population is made. Maybe that is 100 the solution, 50 solution, 30 solution, 40 solution. So depending on your requirement. So the initially, that means it is at random. The solution initial population is generated at random. So that is very important. So once it is generated at random, now we have to go for this. The, see here, generation to generation, the after one generation you are going to get a next set of solution. So how you are going to proceed? So with the initial population, so assign a fitness to all the solution in a population. Now assigning a fitness means what? So each of these, the binary coded GA, which is put in the string. So it will have the fitness. That means it has got the certain value. See, when you put it in the objective function, see, that is why, see, when you represent the process in terms of the equation, input output relation, see, naturally, when you put all the values of the variables into that equation, then you're going to get the value. So that is assigning a fitness is nothing but determining the value of each of the solution and assigning the fitness to all of the solution. If 100 are there, then all the GS strings need to be evaluated and its fitness value it is to be recorded. Now then comes reproduction. See, reproduction, how it is going to happen now. See, from this is the initial population. So from this initial population of 100, so the mating pool needs to be prepared. So the reproduction here means the mating pool needs to be prepared. So this mating pool is also having the 100 solutions here. So how this is done? The mating pool is prepared by means of choosing the solutions from the initial this one. So initially, if there are the 100, the solutions are there in the form of the binary string. So then the mating pool is prepared from this initial the solution of the population that also consists of the 100. So how it is done? So that is the GA operators. These are known as the reproduction, crossover, and mutation are known as the GA operators. So how reproduction is done now? See, that is what I explained. The forms the mating pool by selecting a good solution from the population based on fitness value of the string. Now, what are the different the methods they are used for making this mating pool? See, there are the tournament selection will be there. So proportionate selection and the ranking selection. So these are the different techniques which are used for this one. See, in the tournament, selection. So what will be done? The select the two samples. We will be drawing the small sample. Suppose there are the 100 initial solutions are there. So out of that, we are drawing the small sample of say 4, 8. So out of that, so which are the two best? So this sample is also we are drawing at random, and we are comparing all those the fitness values, and we'll put the one which is having the best, and we are putting back all the initial the solutions back into the that pool, that solution pool. So this continues. Suppose if there are the 50 times, so 50 times needs to be discontinued. Each time you are getting one solution, one the string at a time. So that means after 50 times, every time you are choosing, you are selecting, you are putting it back the solutions, you are choosing out of this based on the selecting that at random and putting that back. Then the proportionate selection. See, the proportionate selection based on the fitness value. So based on the fitness value, it is the strings or the solutions are taken. The ranking selection. So the selection, it is based on the ranks. That means based on the fitness value, all the strings or the GA strings or the solutions, they are assigned with the fitness value, and then we are going to take out this one based on, we are going to assign the rank. So based on that ranking, we are going to make a selection. Now next is we need to make the new solution. So now we have taken the reproduction where we have got the from the initial solution to the next solution, how we have arrived. So we have arrived by means of these processes. That means now also the next the reproduction or the mating pool consists of the same number of the solutions as you have started initially. And then from this mating pool, we need to, because these are the, we need to make the new solution, which has happened till now, it has not happened. Now, So this is going to happen by means of the next GA operation, that is the crossover. So what is going to happen? So the crossover will result into the solutions which are known as the children solution. So we are going to take the two solutions from the mating pool, and then we are going to apply this is the solution which you have taken from the mating pool is parent 1 and then parent 2. So parent 1 and parent 2. So there are the different the crossover operators. In case of the single point crossover, so this is the point of crossover which is also selected at random. It may be here, it may be here, it may be here, it may be here. So it is also the point of crossover is also selected at random. Then in the single point crossover, what will be done? So it will be swapped. See here 1 1 0 0 1. So these two, the part after this crossover point, it is swapped. See, that is a single point. So by doing that, so you are going to get a new string. So what is this new string? It is nothing but the new solution. That is from the two parent solution, you are going to get the two children solution. That means we are going to leave this. Now we are going to have the new solution, that is the children solution. So it will be done like that for all this one. See, similarly here also, here it is a 2-point crossover. So 2-point crossover is again, you see here, this the point of cross section selected at 2 points. Here one it is selected, again it is at random. So what will be done here? So this part left of this first point is also kept as it is, right of that is also kept as it is, and in between that is a swap. And the another the crossover is the uniform crossover. So uniform crossover, what people will be doing, so they will be tossing a coin. See, for each of the bit they will be each solution they will be taken. So each of the bit they will be tossing coin, and if it is the heads, then it is swapped. That means it is changed to 0. Otherwise it is that means the probability will be taken. It is tossing a coin means what here? So the 1 to 0, it is the probability number needs to be generated. If it is less than 0.5, it will not be changed. The bit will not be changed. If it is more than 0.5, then it will be changed 0. If it is 0 is 1, it is made 1. If it is 1, it is made 0. So like that. So that means the probability of each that bit changing is the 0.5. That is a uniform crossover probability. That means that the 50% you can take. So that also you can make 40%, 30%. So these are the different the crossover operations. Then we have another the crossover, the GA operators is known as the mutation. See, mutation is a very small probability which we are going to change the bit from 1 to 0 or 0 to 1. Now, what is the purpose of this mutation? Why this mutation is there? So, if at all there is, the group of solutions are there in the basin, the local basin, to lift the solutions from that local the basin, the mutation probability is used. So usually the mutation probability, it is very low. So this is uniform crossover, the other things. Now, see, another optimization tool is the particle swarm optimization. See, this particle swarm optimization, it was introduced in 95 by Kennedy. See here, the population-based stochastic search optimization tool, which was inspired by the social behavior patterns, that is the bird flocks, swarms, or of organisms that live and interact with the large number of groups. See here, the particle swarm optimization, it is the how the solution it moves, because see, all these are going to start with the initial the population. So these the population, each solution, so how it is trying to improve. So here the from the nature what it is used, that is the movement of the birds, that bird flocks. So how it learns, so that is used. Now See, the swarm particle means what here? So each of the, in the previous we discussed, in genetic algorithm, we discussed that each of the string is going to represent one solution. Here, the particle means, one particle means that one solution. That is the individual solution. So each bird that means the solution is that individual solution. It is considered as the bird or the particle, which is referred as a particle in this algorithm, and that will move with a definite position and velocity in the search space, and composite of all particles are referred as swarm. Note that all particles are evaluated by the fitness function. Now, how the optimization is going to take place? That means the see optimization in all these this it is over iteration. It is not, you know, just after one iteration you are going to get the optimum solution. It has to improve over the number of iteration. So every time you'll find the solution is going to improve. But of course, none of this, there is no solid the mathematical proof how actually the optimization process is going to take place. Now, what's going to happen here? See, each particle is going to change its position and velocity. See, the position and velocity means it is going to gain from its neighboring solutions. So through that, it is going to learn and change and improve. See, every time the bird position, because when the bird flies, what is going to happen? So its position will change. So similarly, here the position of the particle is going to change. Particle means the position, that means the value of the that the solution is going to change. So each solution which is considered as a bird, so after flying some distance, the position, it also depends on the velocity. So the position and velocity are going to change when the particle moves from one position to other position. So that position needs to be compared. See, when the bird has moved from one position to other position, then it needs to be compared. See, now when the bird is moving, that means there are, you know, as we have seen, that is the number of the solutions which acting as the particles. There will be two cases. One is the p best, that is the cognitive leader. That means so far time for that solution whether it has improved or not. So if it is not improved, so if it is improved, that is known as the p best. So that is for that particular the solution, particular particle, so which is moving from iteration to iteration. So if at all it is best from compared to all previous, so then it is the p best. Then we have the global best. The global best means it is the overall best solution so far in that one. So the G best, that means here it is learning from the behavior of the other solutions, other particles, that means other birds. That means the G best and the P best components are used to update and find the new solution. See, this is how the P best and G best are determined. Refers to the personal particle best position and velocity achieved. So this how it is put in the calculated, the new velocity and position. So if you look at the algorithm, how it works, initialize the PSO parameters because it is connected with the velocity and the position. Inertia, weight values are considered. Swarm size. What is the swarm size here? It is nothing but the size of the population. Now evaluating the fitness function of all particles, because this is the part where, you know, in all the algorithm is required, because unless you find out to determine the fitness value, so we will not we cannot proceed to the next stage. Now see, as we are making the comparison, the p best, so if it is the p best value is better, then it will be taken, otherwise it will be dropped only. Then we record the personal best fitness of all particles, find the global best fitness among all particles, then the stopping criteria is applied, and we are going to get the new set of solution. In iteration will continue. Now another the interesting the algorithm in the soft computing is based on the teaching learning TLBO, so which was developed by Professor Rao in the year 2021, because this is developed because of the drawbacks of the evolutionary algorithm, not in fact drawbacks, but especially for the computational time. Because in the previous, the GA parameters, what is the crossover, the probability, what is the mutation probability, what should be the population size. So all these needs to be, they are the specific, the algorithm specific. So to overcome that, so these algorithms without any specific algorithm specific parameters are developed. So it was introduced in the year 2011. TLBO is the population-based optimization, because all we are discussing the algorithms are population-based research techniques. Now here it is based. See, what is the inspiration or the logic which it is working? This algorithm is working. It is mainly the classroom system. That is the teaching learning. As we know, the teaching learning is going to happen in the classroom. And as a result, what is going to happen? How do you measure the performance of the effectiveness of the system? The effectiveness of the system is measured by how the students are performing, what are their results. So the same concept it is used. Now, see, when you take the initial population maybe of 50 or the 100, whatever the population size you are taking, then each of the solution, that fitness value is determined. See, what here will be, who is the teacher here? See, there are two phases here. One is the teaching phase and another is the learning phase. In teaching phase, what is going to happen? So the person who is having the highest knowledge in that group, suppose there are the 100 solutions are there, 100 people are there. So the person who is having the highest knowledge, so he will act as a teacher. And from that, see, some of the knowledge is dissipated, and that is going to gain to the other solutions. That means other strings here. Now, when this is going to happen in the learning, in the teaching phase, so what is the basis to consider one of it as a teacher? So what is the basis? Anybody can?
Sir, this is Dr. Adarsh Anand this side.
Yeah.
I guess the fellow who is the best learner amongst all the learning population guys, he will be called as a teacher.
Yeah, that is fine. But how do you take that this is the highest knowledge? What is the, see, this is now the problem we are considered with the initial solutions.
Right.
Yeah. So it is we are going to find out the fitness value. So the fitness value means the highest value. So the highest value, the solution which is giving the highest value is considered as the highest knowledge. So out of among these all 50 or 100, whatever it is there, so the solution which is having the maximum fitness value, so that is taken as the teacher. And see, the other strings, they are updated based on the learning, the ability to learn. So based on that, so some, of course, the formulas they are used. Whereas in the learning phase, so what is going to happen? In the learning phase, so what really happens, because it is, in the classroom also you can see the learning is going to happen through the interaction among the students. So the same thing here also, the concept is used. There are now, one is the teacher, so all the solutions which are after modification, after the influence of the teaching, so that will be brought to the next phase of learning. So here the learning effect or enhancing the performance, it is based on the interaction. That means the solutions will be interacting with the neighboring this one at random, and the further the change in their values are going to happen. So now, so after teaching and learning phase, the two phases, the teaching phase, learning phase, we are going to find there is a new set of solutions where you will find definitely how do you measure the effectiveness by means of the average performance. Maybe suppose now how you can see now, suppose in the one class there will be 5 subjects. So these 5 subjects are treated as 5 different types of this see the design variables or the variables which are considered as the solutions for the given problem. See here the class performance, the result of the students is the measure. But what is this one? So the number of subjects and the scores that they score in each of the subject. So that matters. So it is going to improve the subject wise the performance, so that the overall the classroom efficiency is going to improve. So the same concept it is used in teaching learning based optimization and algorithm. So this is how the mathematically it is put. Now, see one more algorithm is the Jaya algorithm. So what we mean by Jaya? So Jaya means it is a victory. So here again it is the tuning of algorithm specific parameters is not required. See these are the two parameters. This one which is also developed by Professor Rao in the year 2016. So this is also not requiring any algorithm specific the parameter tuning. So see all the evolutionary algorithms they will not work properly if those parameters are not tuned. Whereas here, so again the parameters are not there. See now, what is the concept here? So how these the process is going to take place here? See now, of course, you have to imagine when every algorithm starts, you have to imagine that there is a group of the initial solution. It is all because based on the population, that is the initial solution. Now, what is the concept which we are using here? See, each of the solutions, see, in that the pool of the solution, maybe 50, 100, whatever you are considering the initial this one. So there will be, some the good solutions, some solutions, the bad solutions, the worst solutions. Now, how we can move ahead? The particular solution can move towards the best. So that is by means of moving towards the best and moving away from the worst solution. So that concept of the is used in Jaya algorithm. See here you can see it is updated. See xjki means what here? So xj is a particular, I is the iteration because the number of the iteration. Then k is the number of the candidate and j is the variable. That means the number of inputs are there. So this will be updated. So tendency of this, see here this one, see R1 and R2 values, it is between 0 and 1. See, of course, how it is determined R1 and R2 after a lot of trial and experiment. So these R1, R2 values they are fixed. So this part is the tendency which is moving the solution towards the best solution. And if you subtract, see here this is with a negative sign. That means it is trying to position itself away from the worst solution. So it is the new solution is obtained as the difference of these two tendencies. So we can put it in the algorithm, the form, initialize the population size number, identify best and worst solution, because each of the solution will move away and move towards. So this is going to happen in this one. Now, so far we have discussed the different algorithms, and now we'll move to the case study. See, case study is also, it can be applied. See why? Maybe I have taken the one case study which is of the machining process, because see, formulation, it is an important part. See, unless you have the good formulation, or formulation means what? Representing the given system in the form of equations. See, unless when you go to any industry or any organization and you are given some problems, they are not going to give the people in the form of equation. But if you want the solution, you need to form the equation. That means you need to put the entire system in a mathematical form. Then solving that, you are going to get the solution. So in order to do that, so we need to formulation. Formulation is an important stage. See why I am taking that also, the formulation part and the modeling part, because see, those equations are required. See, only if you learn optimization, it is, part of it. So another important part before optimization, so what is required before optimization? You need to build the models. Build the models means formulate the process and build the model in terms of input output. Of course, we'll see what are the stages in brief. May not be time to have to go to much of the details. Of course, we'll see the details one. Now I have taken the case study here. See, introduction to machining of the hard materials. All of the materials which are the hardness having the 45 HRC, above 45 HRC on the Rockwell scale, they are called the hardness. So why this problem is taken? Of course, same situation, the process can be applied both. The tools of modeling and optimization. It can be applied to operations management problems. It can be applied to manufacturing. It can be applied to industrial engineering related problems. Also the service oriented the situations. So everything it can be applied. So only thing is you should know how to build the model and apply the optimization tools. So the material are generally classified, so hardness, based on the hardness material, and also because why this problem is taken up. See, the machining of the hard materials is a real the problem, especially where you require the high precision and accuracy. So there the machining challenges are there. So hard materials taken as the example here. Of course, this is the machining methods of the hard material, which may not be much people in. So these are the some of the parts which have undergone the high precision and the hard materials, especially hard materials like the turbines, engine parts, bearings. So these needs the machining of these materials. So some problems were, because see here they are going into the assembly, the type of the fitness and the accuracy, surface finish that is required looking at these parts. So the machining is a real problem. Then see Ishikawa diagram. So of course this is the process I am telling. So this is for the machining process, because see, when you are considering the system for optimization to build that, so before there are certain the things which you need to understand and follow. So you need to identify what are the parameters that needs to be considered. If you do the Ishikawa, see here this part of the diagram. So we'll have all the points which we consider. See, first we decide what are the outputs or the measurement of the system, what is required. When it can be applied to the service industry, like the performance of the airline industry. So there also, if you go to the airline industry, what are the qualities? Now the flight accuracy, delay in arrival, the cost of the flight. So many things you can consider. Also the frequency, connectivity. So all these things you can consider. So for the machining, of course, these are the, so these how you're going to get these things. These are we'll be getting through some the brainstorming session, or the people those who are involved with that system. So through this we are identifying all these things and we are going to find out this. Of course, it will be going into the refinement at the later stage. Now, of course, there are many the modeling. Of course, I'll be taking the brief these things, because I feel it is also required. You should understand how the models are built, and the DOE and response surface methodology are the powerful statistical tools where you can establish input-output relationship in the multi-dimension, maybe linear, non-linear, with a less number of experimentation. So the modeling it is done. That is, modeling is nothing but what we call it as, it is a formulation of the system, the formulation of the system for which you are in need of the solution. So that needs to be modeled before optimization. So the conventional tools, of course, this is one method which the most popularly used by many of the researchers. It is the conventional, it's the regression tools, design of experiments, response surface methodology. So especially the design of experiment in along with the RSM. So one is the design of experiments is making the equation, that is the input output relationship, to the systematic planning, because see, these equations are required, the developed based on the experiment, design of experiment. That means the equation that you are going to develop. See, there are different other ways also. You are going to get, you know, the equation by means of some simulation process, or you may derive it by the empirical relation. Also you may get the equations from the literature, but doing the experiment and developing the model, there are certain the basic advantages. What advantages you'll find? It is going to consider the local environment factors in the modeling. See, there are many factors which you know, the environmental factor might be missing if you are, you know, using the some other the techniques of modeling. So design of experiment, people feel it is going to give more the realistic the input output the relations. So of course this here what we are doing here, of course we'll discuss the methodology in brief. See, experiments are conducted and then use the response surface methodology like the central composite design, box Venkan design, Taguchi design, etc. See, see, what is the methodology it is considered here? They decide the important input parameters that affect the process, the first point. So unless and until you identify all the parameters which are affecting the system, it is the solution what you are going to get may not be the good if the formulation is not right. So you need to consider all the input parameters. So what is the method here it is used? It is used from the existing literature you can do, or you can consult the people those who are working, or through the brainstorming if it is the process is new. If you leave any of the important parameters, then the solution what you get may not be worth considering. So all the important parameters needs to be collected. Then the planned experiments measure the responses. Now see here, see what is the performance you are going to like, what for what solution you are going to need. See, if it is you know, efficiency, revenue in terms of the efficiency measure, how you are measuring the efficiency, whether the quality of the product in terms of, you know, certain the parameters. So you need to decide, so what are the responses that can be measured. See, one thing is it is difficult to put the, if the response is in the qualitative form. If the response is in the quantitative form, easily you can measure and put. Now conduct the experiments as per the design of experiments. So this design of experiments, it is the systematic way of conducting the experiments. Now suppose there are the 5 input parameters are there. So for each of the parameter, you have to find out the extreme limits, that means levels. What should be the minimum value? What should be the maximum value? And in some cases, in between also, you need to consider. So for all the input parameters, you need to identify what are the important, what are the levels, because what is going to happen if you take a very the narrow range, then you may not get some of the important information you might be missing. Or if you take too wide, there may not be any response, there may not be any relation, there may not be any response surface, so it may not be much useful. So that is why selecting the parameters and their levels is more critical. That is the first step for your the getting success. Now develop the regression model. See, once you the collect the experimental data, of course the full factorial design. See, full factorial design, see this what is the number of experiments that are required in case of the full factorial design? So it is the 2 to the power n. That means what is n? N is the number of input parameters. It is at 2 levels. Each input parameter you're considering at 2 levels, and then you are the total number of experiments. If suppose there are 3 parameters, then it will be 2 to the power 3. That is 8 experiments needs to be performed. If it is 4 factors are there, then it is 2 to the power 4. That means 16 parameters, 16 experiments needs to be considered, needs to be carried out with the different combination of these input parameter values. So that means you need to conduct the experiments with the input parameters set at the different combination of their levels. So if it is 5, so like that the number is going to increase. So usually the full factorial design is used when the number of parameters are more. If the number of parameters are less, if it is more, you can go for the fractional factorial. So where because see, the accuracy of the regression model, it depends on whether you are considering the of course all the main factors, interaction factors, and the 2-factor interaction, 3-factor interaction, 4-factor interaction. So as the number of factors increases, so their interaction, if there are 5 interactions, 5 factors are there, 5 inputs are there, so the interaction effect of all 5 parameters on the response may not be much, so it can be neglected from that point of view. So of course the central composite design will see how geometrically it is represented. So once the model is prepared, then what will be done? Once the model is prepared, so it needs the 2 stages of verification. One stage is the statistical verification, whether the equation what you have made is statistically significant or not. If it is insignificant, means what it is going to increase, what it is going to show, it is going to show that the factors what you have considered have not the much impact on the response. So there might be some other factors. So the first analysis or the statistical analysis itself will indicate whether there are any the main factors have no impact on the parameters on the response. So that will be represented. So the general form the linear multiple and the second order polynomial you're going to get here. Then once you do, so that will be done through the significance test and ANOVA test. Then validate the model for the practical use through the test cases. Then there is a validation, because once after the statistical significance and adequacy, there is a need to find out how much suitable this is for your practical purpose. So that can be done by means of conducting some test experiments by using the input levels which are generated at random, conducting the experiment and measuring the performance. So one value you are getting through experiment and the other value you are getting through the equation, make the comparison. So that is going to give you the results. Now how it is represented? See, this is the design matrix for full design. See, there are A, B, C. 3 factors are there. 3 factors are there, A, B, C. So each one you will have the at 2 levels, plus, minus, plus, minus, plus, minus, and these are the response values. So that means the experiment 1 is conducted with the parameter set at -11, -1, -1. So you are going to get the value, the response value. That means the measurement, conducting the experiments with this as the lower value, all the parameters, and then measuring the response. So that is going to give you the response. So with 3 parameters, linear one. So the design space, what you go, so each of these points, so this will be represented here, -1, -1, -1. So here, so all is the represented by the corner points of a cube. So this is the full factorial. Now, when it is the central composite design, so we'll have it is see, the nonlinear models you cannot build with the factors at 2 levels. So it has to be done minimum at 3 levels. So some star points are added here. See, star points. That means star points means, so this is the level at which each of the parameter it is conducted apart from these points, apart from these 8 corner points. So these are the star points. Star points are at some distance alpha from the center point. So this will be naturally more than 1. So the alpha value might be 1.1, 1.2. Of course, most of the researchers we find they use only this alpha is equals to 1. See, if alpha is 1, what is going to happen? These star points will be on the faces of these cubes. So it becomes much simpler. Whereas if you put the star points away from the face of this one, where alpha value is more, then you need to conduct the experiments at 5 levels. So this is the center point. Center point of the cube is also required, where the number of times it needs to be repeated. See, in all these experiments, they need to be repeated and done at random. See, this is the standard order, but then they need not have to be done this at the standard order, because there will be biasing. In order to avoid biasing, it needs to be done at random. So by conducting these experiment depending on the parameters, here it can be represented because it is only 3 parameters. If it becomes 4 parameters, 5 parameters, we cannot represent graphically easily because it becomes multidimensional. Now, see this building of this response equation. See, this is the response equation, this is the response equation. So what actually really it is happening, if you imagine, see, there is the response surface. Response surface means representing the relation of input with the output. So what you are doing through this the process of this building this regression, so you are developing the response surface which is closer to the real surface. It may not be possible to have exactly the true response, the input output, but these will help to get the response surfaces which are closer to the real response surface. So that is what is the doing all this exercise will lead to that. Now this is another design where the points are, this is a box Benken design, another design where the points will be away from this one. So this is how the table looks like, the analysis of the regression tools, where you are going to find the nonlinear and linear regression models. This is the results of how the formats it looks, because maybe it is very interesting if any of the teachers are here, those who are doing the research work. So it may be really helpful how this statistical combined with the soft computing will be the best. Now see, most of the soft computing tools they need, especially if you need to build the models as well from the soft computing. There are certain tools like the neural networks. So neural network is a modeling tool, like the response surface, what we have used, design of experiments, all those things. You can use the neural network to build the input output relation. But of course, that is there, you don't have any the mathematical formula, all equation, etc. will not be there. So what you need to do there, you have to use the training data to train the neural network. You have input and output the data. So that data that needs to be trained, and also only the neural network in the feed forward direction will not be helpful. See, it will consist of the input neuron layer, hidden layer neuron, the output layer neuron. Input layer neuron represents the number of the input parameters. Hidden layer, so you'll have to determine, and the output depending on the number of responses. See, when you make this one, of course, I think there is not much of the time to explain that how the neural network works there, but it needs the neural networks. They need some algorithm to optimize the parameters. So the neural network which needs to be trained cannot be directly the feed forward neural network can be used. It has to be trained, and the parameters needs to be optimized, and for that we should have some algorithm, like the back propagation is one algorithm which is used to tune the parameters of neural network. So once the neural network is trained and tuned the parameters, so that can be used to make prediction. So directly you can put input, so you are going to get the output, but without training is not possible. So it needs, because see, when you have the more amount of the data, better learning effect. See, if you have the got very less input output data, 10, 5, then the neural network may not be trained properly. So if you got the hundreds, thousands of data, the neural network parameter tuning will be much better. So maybe conducting the thousands of experiments may not be feasible. So what will be done there? So they will be using the equations what we have used now. See what people will be doing. Initially they are developing the equations, and then they are using those equations to, because once you have the equation, you can generate thousands of data. So using those equations, generating the inputs at random, passing through that equation, you will get the output. So that input output data can be used as the training data. Now coming back to our hard turning process, of course I have taken this as one application. It can be used to the number of applications for all operation management, industry engineering, etc. So what is considered here? So the hard turning process, feed rate, nose radius, depth of cut, cutting speed, and the output which are measured by doing experiment are the material removal rate, surface roughness, cylindricity error, and circularity error. I will not go into much of the details how these parameters are obtained. So we need, as I explained, see the cutting speed, the low value, because as I told, it should have the high and minimum, plus one minus one, which is plus one here. So this is plus one, this is minus one. So the parameters, input factors are set at higher and lower level with the middle, and now the experiments are conducted. See, the experiments are conducted as per the design of experiment with a different combination. For example, the measurement of the material removal rate or the surface roughness is measured by performing machining with 100 cutting speed, 0.1, 0.2, 0.4. So the surface roughness is measured. So like that with a different combination, this one, this one, this one. So all combination, different combination as per the design of matrix. So they will be done. Experiments will be done in order to develop the response equation. So this is how the machines are used. The CNC machine is used for turning. This is the tool, and the different the equipments are used for machining. And cylindricity error and circularity error, how it is measured and its importance. Will not go into the much of the details. Now, see, this is the table input output. See, now after doing the experiment, so we are going to get these are the responses. Response 1, 2, 3, 4. So these are the responses. So this is the combination. See, that means this 28 number of experiments are performed, and the results of the responses are measured. So now we are developing the equation which will represent these material removal rate, surface roughness, circularity, and cylindricity. See now, surface roughness, there is how many response equations will be there? It is not the only one response equation. There will be 4 response equation. One response equation for the material removal rate in terms of this. Then surface roughness, one more equation representing in terms of this. Circularity in terms of this. So we will have 4 different types of the response equations, regression equation. So these regression equations are the basis for the optimization process. So why I am explaining, so how you will arrive at the problem of the optimization. So by conducting experimentation, you are doing systematic way of the experimentation, developing the accurate input output relationship, and those input output relationships are used for the further process. Of course, this is the ANOVA test results for those results one. So this is how the statistical validity adequacy that is determined, which we discuss. So these are the material removal rate. Now see here you can find, so this is the one equation, 2 equation, 3 equation, 4 equation. So what is the use of these equations? So these equations now, so once you do that 28 equations and put them in the form of this response equation, you need not have to do the experiments. So directly if you put for the any input variables, so if you put, so it is going to give what will be the material removal rate, what will be the surface roughness. So see, in the industry, what people see, ultimately we are trying to find what is the best combination of these input parameters for the highest material removal rate. So maybe in isolation I'm telling. So for that is we are moving towards the optimum. See, people will be looking for, of course, this equation will give you what it will give you, what is the value of that response, but it will not give you the information what are the inputs that will give you this material. See, what really required for the people what should be the value of the input, the parameters, so which will result this much of the metal removal rate, this much of the surface roughness. So that is more important, where the people will be looking, and there we are going to go, we need to go for optimization. Of course, we'll see the multi-objective optimization as well. See, now here what is going to happen, see, if you do the metal removal rate, one equation, not considering any other, if you do only this one, so that may have the negative impact on all this. You may get a very good metal removal rate, but the surface roughness may be poor, circularity error may be poor, so all this might be poor. So you cannot do this in alone, because your system, it is represented by how many objective function? 4 objective sum functions. So it is called as multi-objective function. So optimization of a multi-objective function is very important. See, most of the real situation what we find, so they will be in nature the multi-objective optimization problems. So you need to solve this multi-objective function through optimization. So you are going to get the solution, so which will have the desired outputs. Now see, now here, now see, there is a necessity to convert the multi-objective into one objective function. Of course, there are the different the techniques they are used. Now see, if this is the response surface, which is in the multi-dimensional, represented by for those things. Now you can see here there are the, whether you need to minimize or maximize that the single objective which is converted. So this might be minimum, this might be minimum. So again here the local maximum values, the maximum, the global maximum, local the minimum, global minimum. So it depends. See here you can see there is a multimodal, 1 peak, 2 peak, 3 peak, here 2 peaks. So it depends on the really, see, this is going to, you are going to get when you have the really established the equations. So those equations are going to be represented here, whether it is a unimodal or multimodal, but in most of the cases it is a multimodal only. So here if you look at, that is an interesting problem. See, the material removal rate we try to maximize, whereas the surface roughness has to be minimized, errors minimized, cylindrical error minimized, whereas these three needs to be minimized and one needs to be maximized. So what we have to do, so we have to convert this into the maximization type. So by multiplying with the negative, I think you all know, by multiplying the other side of the equation negative, so this becomes the maximization type, which can be used as a single point. So the multi-objective optimization is carried out to maximize this one. So the objective function, multi-objective function to single objective function, that is after conversion, I told see, after conversion it is converted to the single optimization function, the objective function. So we are using the desirability function approach for this the purpose. So here also you need to, how much importance you want to give. See, there are the different cases, so maybe the different applications might be different. See, some cases where the material removal rate might be higher priority, whereas these are the lesser priority. On the other hand, sometimes the surface roughness is more critical, as you have seen in some of the products which are the machine products. So depending on that, you can give more weightage. So in that approach, what we are converting, so you can give either the equal weightage, or you can give some the more importance depending on the user, depending on the application. So you can vary the weightages on these variables and develop the equation. So here you can do. So we'll find the desirability function is used here. See how this can be done. Single objective function, that is how it is converted into the single objective function. So now the different 4 cases are also considered. See, the case 1, where the equal weight was considered, that are 4 are there. That means 25% weightage to each. Highest weightage to one of the output, depending on the priority. 7%, 70% weightage is given, and rest of the 3 are given 10% each. Then the case highest weight to, so each of the giving highest importance to one and the remaining equal. So of course you can, it depends on the user. So you can set any of these weightage values depending on your priority, which is more priority. Now see what I, now again coming back to, see now we are coming back to the application of those the techniques, the GA techniques, that 4 techniques what I explained that. So there you will find the application. See now what I told, the genetic algorithm. So it is a algorithmic specific parameters, the probability of crossover, probability of mutation. So this the size of the population, number of generation. So these are the requirement. See, unless you get the values of the what should be the crossover probability, different crossover probability may give the different the values. So the GA to work better, you need to fix these values by parametric study. What we'll do in the parametric study, we'll keep all other parameters at one fixed, and we go on varying only one parameter at a time. See, probability starts from 0.7, then it will be varied. So the value of the fitness value, the overall fitness value of that, so we are going to find out. So this is going to get, so where we're going to get the maximum fitness, so that will be, see here, after this again it's going to decrease. So similarly for all the algorithm specific parameters that needs to be optimized, so which we are doing. So similarly for the inertia weight, swarm size, because this is a different algorithm. So these are the results what we obtain. So some experiments are conducted to validate. Now, of course, the summarize the conclusions. All these statistical tools and modeling tools can be used, and for the optimization algorithms which are based on the soft computing are applied to determine the best values, the solution in terms of the best parameter values. Different 5 scenarios are considered. So we find, of course, this is related to particular the problem which we considered. So these are some of the references. So this is my contact details. So now, I think we are coming to the end of my presentation. I thank Dr. Sridhar, Dr. Santosh for giving me an opportunity to address all of you and express my views regarding the topic. I thank the CSIT management as well as all the team of CSIT. Thank you.
Dear participants, Sir concluded his session. Please put your queries. Sir is waiting for your queries. Participants, if you have.
Sir, is I audible, sir?
Yes, you are audible.
Yes.
Ask the question.
Yeah, audible.
Yes, sir. Just like an example in steel industry, just like we are running a blast furnace, and we are having n number of raw materials, sir, and we have to maximize, or what we have called that we have to minimize the slag rate, and we have to increase the
minimize the slag. See, it is particular to that. See, you need to consider what are the factors which will create the slag. That is, one is the impurity.
Right, sir.
Impurities that are present in the scrap water you're using. See whether you can measure that and quantify. And then what other the additives which you are using. And
Right, sir.
then the other parameters like the temperature and the environment in which you are melting. So all these that needs to be considered. Of course, it is see if it is that is why the new problems are really interesting. So you need to go for this brainstorming. See what are the factors which are affecting the slag formation. So how
Right,
you
sir.
can put into this one? You have to do a number of trials, especially when the things are new. You need to do a lot of the work to identify the parameters. Because see, well-established process, you will have the system, you know the parameters. But especially when you are not sure what are all the factors and you want to relate, of course, it is a good, the interesting problem you have taken. So that is fine. So only thing is you need to look into these aspects.
Thank you, sir.
Any more participants? If you have still any queries, sir has shared his contact number and mail ID. You can correspond with Dr. Mahesh sir. Thank you very much, Mahesh sir. Today you enlightened us related with need for mathematical formulation to solve the problems. What are the importance of mathematical formulation? And you have given the clarity about local minima and global minima, how to differentiate them. And you have given the awareness to us related with the genetic algorithm, particle swarm optimization, teaching learning based algorithm, J algorithm, and related with analysis of variance, what is its importance, how it is applicable for the optimization problems. And you have nicely explained the case study related with misting operation. Thank you very much, sir, for sparing your valuable time.
Thanks.
Then hope we have fruitful interactions in future also. Your cooperation is required.
Yeah.
Sir. Thank you very much, sir.
Okay. Thank you. Thank you, Dr. Sridhar and the team. Thank you. Okay. Bye.
Bye, sir.